Hello, let's now talk about libraries, linkers, and loaders, which are different concepts. They are connected, and we'll talk about how they're connected as we go through this video. Starting with a library. So a library is a collection of pre-written sections of code. Someone else has written these and I'm able to utilize them. Libraries are not always open source. They can be closed source, they can be free, they can be paid for, but essentially someone else has written code for me to be able to use in my program. So for example, if we import, say, what's called a module in Python, that's me allowing access to that library. Here is a random library, which has different subroutines relating to randomness. And I would say subroutines are the most common pre-written bits of code we would utilize, but you can also sometimes have constants provided via libraries. And you also might have, for example, class definitions provided via libraries as well. Bottom code here contains some machine learning code where we are creating an object based on a class definition already written in a library. So I'm using those bottom two examples to emphasize that it's not always subroutines we are using, although subroutines are the most common things we would use from a library, I would say. Now, what are the pros and cons of using library code? This is someone else's code we're using. Well, a key benefit is it's already written for me, so therefore I can use it and it will speed up my own development. Sometimes you as a programmer don't have the skill or the expertise to be able to code certain things, and you might therefore want to use library code, which covers those difficult tasks. And especially if it is a well-known library, it may have been extensively tested. It might be really well-known, really popular, and so you can trust the code works correctly. You've not got to spend time testing it yourself. However, if there are errors or you're finding it difficult to get working, it's quite hard to debug, especially if it was a closed source library where you can't see the source code. It's very, very difficult, if not impossible, for you to debug it. But even if you could see the code, even if it was open source, it's not your code. And so it would take longer to try and understand it. And that's kind of a separate point too. It's not your code, so therefore you've got to learn how it works before you can utilize it. That might negate some of the benefits of it being already written. And because we are just integrating someone else's code into our program, this could increase the file size of our executable, especially if the linker isn't doing a very good job. Because one of the things which linkers are trying to link is library code. A linker is a program that combines object code files and any required library code into one executable program. So we have a linker, which is a program. Often we visualize this as being part of a compiler or something which runs immediately after a compiler. And it will take different object code files. We mentioned in the compiler video that object code is produced in code generation. Object code is kind of incomplete machine code, and it can be incomplete because we haven't linked it yet. You might have multiple different code files, each one in object code. The linker has to combine these together. And if you haven't got any libraries being used, it will just combine these. If you have got a library being used, it needs to combine it somehow into the final executable program. The simplest way to do this is simply just to copy the library code into the executable so that the random module is copied into my .exe file. A sophisticated linker will only copy what is required, but that's still adding file size to your executable. A slightly cleverer but risky approach to linking is called dynamic linking. This is where we're not actually copying and pasting the code in, we're simply creating a pointer towards the location of the library on your computer. So the benefit is we're not actually adding any more file size to the executable, but we are assuming the user has the library installed. It won't work unless the library is somewhere on their computer. And so if I tried to send this .exe to my friend and they didn't have a library installed, they would get an error if we were using dynamic linking. If it was static linking, it'd be fine, just it would have a bigger file size. And lastly, we need a loader to actually get our program running. A loader is really part of the operating system. Like I say, you can view a linker as being kind of part of compilation, and the library is just a bunch of code on a computer. A loader is really part of our OS. And this is what runs when we double click our executable and try to get it running. There are a series of steps a loader will go through in order to allow this to happen. First of all, it needs to allocate memory for our program. So allocate some space in RAM. It will then load it from secondary storage into memory. Don't forget that programs are stored long-term in secondary storage, but can't actually run until they are in RAM. If your program has used a library and you've used static linking, then the library code is already packaged as part of that executable. However, if we had used dynamic linking, the library code isn't part of the executable, we need to load it before it starts running. So the loader will load the library code from secondary storage into memory as well. And then after that point, after we've done all this loading, the name kind of says what this does, we can then pass control over to our program and the program can continue. The loader doesn't need to be involved anymore at that stage. Now, there's lots of related concepts in this and the last few videos. So hopefully this diagram summarizes where we are at. We're starting with some source code in a high-level language like C++, for example. And the end goal is to get this program running on our computer. We first of all just might decide to compile it. We could interpret it as well, which is a whole different process. But if we decide to compile it, we go through those 4 stages. It will produce object code potentially. If it produces intermediate code, that's a slightly different process where a virtual machine gets used. If I've got object code, it's not ready to run just yet. I've got to run a linker to connect it all together. And if I have used a library, we need to somehow integrate that into our executable file. When I want to actually run it, the loader will allocate some memory space for it, load all the required things into memory, and then we can get on with running our program.